So in this unit, we're going to continue our study of medians and centroid. Just a quick recall. Median is a segment that's joining a vertex to the midpoint of the opposite side. And the three medians of a triangle, intersect at a point called centroid. So if you look at this diagram here, P is where all the medians, and look at these DEF points, these 3 points are midpoints. And so AE, EF, and BC are medians, and are medians, and P is called centroid. And then there's some characteristics about centroid and medians. So first of all, we're asked to list all the medians, and as I said, it's AE, BF, and CD. And the name of the centroid is P. And there is a special property there exists for median. You can prove it, but it's actually a fairly challenging proof. But for this level, introductory of geometry, all you need to know is the median is a 2/3 point of, the centroid is the 2/3 point of the median. So in other words, look at my AP. AE is my median, so AP is twice as long as PE. The gold part is twice as long as the purple part, right? And another way to write it is PE is half as long as AP. And you can also say that AP is 2/3 of AE. Establish the relationship between AP and AE that way. And for the same reason, PE is only 1/3 of the entire length of the median, which is AE. So obviously this relationship works for the other two medians as well. Works for BF and CD and the various segments on them as well. So I'm only using AP and PE as an example here. Okay? So median and centroid are quite unique that way. Let's look at some practices. I didn't break them down because we're going to jump around a little bit. When I jump around, just a reminder, pause the video and finish all the problems in between. Okay? So let's look at the first one. It says that if P is the centroid of the triangle JKL, so if I know that P is the centroid, then I'm talking about medians. So these must be congruent because they are midpoints. And I also have that 2/3 relationship that I mentioned earlier. JK, total length on this side is 22. KN, only half of this is 13. So if KN is 13, NL has to be 13. OL is this half is 18. That means this half has to be 18. So that's all the information that's given. Let's see what we're asked to do. KM has to be half of KJ, which is 22, multiplied by 1/2. So I have 11. NL, as I observed earlier, is 13. KL, so KL is 13 plus 13, so it's 26. JO has to be 18, as I observed, and JL has to be 36. Okay, and let's look at number 3. If G is the centroid, so that means I've got a median here, and AG is 8. GF, where's GF? GF is 7. And BG is 5. BG is 5. Right? So without looking at other things, what the question is asking me to do, I know it's a median. I know that a portion of the median is given, and I know that 2/3 relationship that we just talked about. So let's see if we can draw some conclusions and draw information out of this diagram before I fill in the blanks. I know that GF is 7, and GF is the short leg of that median. So CG must be twice as long at 14. And I know AG is the longer left leg of the median AD. So AG is 8, GD must be half as much. For the same reason, EG must be 10 because that's the longer leg of that median. So let's see. GD we said is 4. AD. So AD you have to do 8 plus 4 to add the two segments together. CG I have 14 as I observed. GE I have 10. And BE I have 10 plus 5, which is 15. Okay, so that's how you calculate the length of the median by using that 2/3 relationship of the centroid. These are pretty straightforward. Let's see. Yeah, let me do number 5. So again, J is the centroid, then I know I've got medians and the 2/3 relationship. DH, this whole thing is 51. So DH is 51. Then I have to break it down into 3 parts. So this part has to be 17, and this part is 34, right? GF, where's GF? GF is the other median. So right here, this median is 60, and EI is the third one, is 57. So let's see. I'm going to use, maybe I'll break this 60 down. So this part should be 2/3 of 60, which is 40. This part is 20. And then I'll do, this is 57. So which means this small part is 19, and the longer part is twice as long, 38. So now I know DJ, where's DJ? DJ is 34. JH is 17. GJ is 20. JF is 40. EJ is 38. And JI is 19. Okay, so this is, again, this is how I do it. Excuse me. As soon as I get the information, I know the theorem, so I mark it on the diagram, and then I go for the answers. So you don't have to do exactly in the same sequence, but I think pretty much for this chapter, they are all fairly similar. And the vocabulary is so confusing and can be so confusing. So I like it, you know, in my head, I have a diagram. If it's a centroid, it's related to median. If it's circumcenter is related perpendicular bisector. So with each property, each theorem, each vocabulary, I have certain criteria that I remembered, and I mark them out immediately. So that helps me find out what works for you and stick with it, as long as it's consistently correct. If you know that you're consistently making mistakes in one type of errors, that's when you should look for a different method. So that's just a study tip there. I'll do the last one with you. If H is the centroid of this triangle, BDF, so centroid, I have midterm to vertices. There we go. And I also have the 2/3 relationship. DF is, this part is 50, so DF is 50, and CF is the entire length of this median is 42, which means is 14, is that 14? And 28. And BH is 22, which means HE is 11. Then we have to find the rest. we're asked to find HE. We said HE should be 11. EF should be half of 50, which is 25. HF is 28. We already marked it out. DE is half of DF, which is 25 as well. And CH is 14, as we marked out. BE is 21 plus 11. I should have 33. Okay, so you see it's very similar. It really is just using the concept, the embedded concept that centroid is a median, is related to a median. It's the meeting point of all three medians, and it has a 2/3 relationship in terms of the two segments cut off by the centroid. And then the rest of it is pretty much common sense. Two new concepts. Altitude. Remember, another word for altitude is just simply height. In a way, we like this the best because it gives us right triangles, which always makes things a lot easier. So quick review. Altitude is this segment joining a vertex to the opposite side that's perpendicular to that side. So I have to have this right angle sign there, okay? And altitudes can be inside or outside of a triangle. So if you look at this one, this is the altitude right here. If you look at, if this is a right triangle, this leg here is my height or my altitude, right? But if you look at the obtuse triangle, if I drop a stone, if this is the Pisa Tower, I drop a stone there, and this altitude gets extended beyond outside that right triangle, because that's outside that obtuse triangle, because that's where I can find my 90-degree corner there. So this is my height or my altitude, but it's outside that triangle. Now, it happens so that the three altitudes of a triangle intersect at a point called orthocenter. So in this diagram is here, and as soon as I see orthocenter, that's what I mark out. I highlight that. So the three altitudes are AE, BF, and CD. And then that's it. So this is pretty simple and straightforward. It just says that the only information that it gives you is that it's perpendicular to the opposite sides. Okay, so let's do a quick review. Again, if I tell you circumcenter, the first thing you need to think about is its perpendicular bisector. What more information does it give you? The bisector tells you that you have two congruent segments on each side. So that gives you some information that you can work on, right? So that's circumcenter. And the three angle bisectors of the angles of a triangle intersect at the incenter. The incenter is about angle bisectors, so it cuts the angles by half. The three medians intersect at centroid, and that's the one we practice a lot in this video. And the three altitudes, as we mentioned above, is called orthocenter. And a circumcenter is equidistant from the vertices of the triangle. This is really important. Whereas an incenter is equidistant from the sides of the triangle. Okay, so make sure that you go through this review a couple of times, understand the differences between circumcenter, in-center, centroid, and orthocenter. And also understand that, remember, median centroid, that's the one that has the 2/3 relationship, and as well as these are important. Circumcenter is equidistant from the equidistant from the vertices, whereas the in-center is the equidistance from the sides of the triangle. Don't just remember it, but remember how their in-center is related to angle bisectors. If you have the image of an angle bisector, you will understand why it's equidistant to the sides. Same thing works for the circumcenter, is the perpendicular bisector, right? Name that center. Based on the markings, classify each of the centers below. So first one, obviously, I've got angle bisectors because these segments are cutting each angles by half. So the first one is an angle bisector. Second one, I have right angle, and it goes from one vertices to the other side. So this is altitude. Third one, I'm cutting each sides by half. So these are midpoints, and therefore I have medians. Fourth one, be careful with this one. I have, first thing I see is the right angle. So what comes to mind is altitude. However, I have additional information that it also bisects each of the sides. So this is a perpendicular bisector. Oops, let me move it up. Okay. So number 5. Number 5 doesn't give me much information other than this point. From this point to the distance between this point and all the vertices are congruent. So with that, that should be a circumcenter. Remember, circumcenter are the perpendicular bisector. So if I draw a perpendicular line here, I should have that bisect one of the sides as well, right? Number 6, it looks to me, I have midpoint here. That's it. It doesn't say if it's perpendicular or not. So these are medians. It's connecting the vertices with the midpoints. This one I can have altitude. What else can I have? I think there's a mistake here actually. There should be a marking of these. So that means that these 3 segments are congruent. They're equidistant to the sides. So in this case, if I have these markings, I would make the conclusion that this is in-center. And number 8, what do I have? Number 8, I have right angle here. So these are either altitude or perpendicular bisectors. In this case, they are altitudes because there's no markings indicating this segment and this segment are congruent. In fact, just a visual inspection tells us that they are not congruent, so it's just altitudes. So again, you have to have these little tick marks to indicate their congruency. Otherwise, you cannot draw the conclusion, okay? This is an easy one now. By now, it's an angle bisector. And this gives you 2 pieces. Information should be easy enough as well, right? These tick marks are bisectors. So that's it. And finish your homework, and I'll see you in class, guys. Thank you. Bye-bye.